Let's do one more example. That's a very simple example of a Bode plot. And we're going to do 1 over s. And we're going through these really basic ones because they're kind of the fundamental building blocks when we have more complicated systems. So we'll just walk through this one, and it's really important that you understand how this affects how an s on the bottom or on the top, so a 0 or a pole, affects the Bode plot. So we're going to look at this now with 1 over s. So this would be looking at a pole, and this would be a pole at 0. Let's just go through the same exercise we did before, looking at how the magnitude and the phase changes as we change our omega value, so as we increase in frequency. So again, let's start at just a 1, because that's pretty easy. So this time, our s is equal to j1. So maybe I'll change this from s before they were the same. So now we'll just look at, so we'll put s, and we'll put, I guess, g of s here. So here we have j1 as our s. But what that means is 1 over j here, which we know if we multiply that around, we're going to get negative j, right? So you multiply by j over j, and then you get the numerator becomes just j, the denominator becomes a -1, we get negative j. Okay, so that's our value. And now if we look at the magnitude of that, it's only just a 1, so we get a 1 here. And if we look at the phase, so we're looking at the phase of this, negative j, the phase of that, well, if we look back at our axis, right, on our imaginary and real, negative j is pointing in the downward direction, so that's going to be a negative 90 degrees, or negative 90 here. Okay, so let's plot that point here, 0 again. And, oh, sorry, we did 1 here. If we put 1 into dB, right, we get 0 times 20, so we get 0. So I guess I should write it in dB here technically. Let's do that. Okay, so here's our 0 here. Okay, dB, I'll label it. Okay, 0 dB for our magnitude and negative 90 for our phase. Okay, so let's do, again, now 10. So we'll do j10 as s, which means we get 1 over j10, which is going to be a negative j1 over 10. Okay? So if we look at that now we have 1/10 going into here. So we look at the magnitude, that's 1 over 10. If we look then at the log of that, so we take the log base 10 of 1 over 10, we get negative 1 times 20, so we get negative 20 dV. And our phase is still going to be the negative j direction, so it's still going to be negative 90. So let's plot that. So 10 now gets negative 20, and we still get the same approximately. It's supposed to be a line. Okay, so we have a few points. Let's do a few more. So let's look at 100. So here we have j100 as s. We put that into our g of s. We get 1 over j100 is equal to negative j1 over 100. Okay, so if we look at the magnitude of that, it's 1 over 100. Take 1 over 100, put it into our dB equation here. We'll get log of 1 over 100 is negative 2. Negative 2 times 20 is negative 40. And again, our angle, same, negative 90. Okay, hopefully you're also seeing a trend here. So we're at negative 40 and negative 90 here. So we'll do one more point. So j 0.1, and we'll put that into our g of s. So 1 over j 0.1. And this time, if we move everything around, we've got negative j10, right? Because 1 over 0.1. And when we put that into our log equation, this time we're going to get log of 10 is 1 times 20 is 20 dB. And again, angle, still negative 90. Okay, so here's 0.1. Here we are, somewhere in here. And negative 90. We'll write it out, but you can do the steps for the very last point. You will see a nice trend. We'll get negative J100 here. Pick the log of that, log of the magnitude, right? And then we'll get positive 40 dB and still negative 90 degrees. So our last point here, negative 90, positive, 40. So if we look at the trend, we'll see that now we have a line. Before we were going up, now we're going down. So when we looked at just S, we were increasing. Now it's 1 over S, we're decreasing in the magnitude. And our phase shift is exactly negative 90, and it would stay at that point. And if we look at our decibel change per decade, this time we have a negative 20 dB per decade, which is pretty much exactly opposite of when we just had G of S equal to S. So if we have an S in the denominator, it will contribute this kind of decline. And if it's in the numerator, it will give the opposite increase. So this will be important as we look at more complex systems. But the important thing to remember is that you take this, plug it into these different equations, and we can look at various points, test various points of omega, and figure out how our system is changing at different frequencies. How is the magnitude changing and how is the phase changing? So this is the Bode plot for 1 over S, and we'll move to more complicated ones next.